All right, so this recording is just going to be me going through all of the problems on the review and like writing them out so that you can see exactly how I solved them. Okay, the first problem says Rosa boat is paddling across a 13.2 meter river at 1.25 meters per second relative to the water, which is flowing at 0.5 meters per second downstream. What is the resultant velocity of Rosa's boat? So you see at the picture I've drawn our stream. The water is in blue, and then Rosa's boat is in black. To find the resultant velocity of the boat, we're going to find the hypotenuse of that, and we'll call that the R value. And then remember, we also have to find an angle to go with that. So to find the R, we would do Pythagorean theorem. So we end up with 0.5 squared plus 1.25 squared, and that'll equal our R squared. When you plug that into the calculator, it equals 1.35 meters per second. And then to find the angle, I'm just going to use tangent. You could use sine, cosine, or tangent. It doesn't really matter. Tangent would be opposite 1.25 over 0.5. So I do the inverse tangent to get rid of that tangent on there. And the angle is 68.2 degrees. And the direction that we would say for this angle would be across from down. I realize on the actual review sheet, I wrote 21.8 degrees down from across. Notice it's just the complementary angle to it, and the directions are switched on there, so that's totally fine to have either one of those angles on there. Okay, so this part of the question, or part A, says, how long will it take Rosa to cross the river? Well, we want to know specifically which velocity is going across the river, and it's the velocity of 1.25 meters per second. That's the one that is pointed across the river. We're trying to find how long, and we are told in the problem that the river is 13.2 meters wide, which is displacement. For all relative motion problems, the acceleration is 0 because they're constant velocities. So the equation we use is this one. But this second half of the equation just goes away because it's 0. So we plugged in our numbers, we get 13.2, 1.25. We're solving for time, and time would equal 10.6 seconds. For this question, which says how far downstream does she land, now we are looking for a displacement. We look at the velocity that is pointed down the stream, which is the one talking about the water flowing at 0.5 meters per second. We know that it took 10.6 seconds for her to get to the other side, so that's when she will land. And then again, our acceleration is 0. We end up using the exact same equation. Our acceleration of 0 means that the last half just disappears, so we end up with the equation looking like this. And if we plug in our numbers, we have 0.5 and then 10.6. If you multiply those out, you should get 5.3 meters, and that's downstream. Okay, this problem is kind of a complicated one. It's one of the vector problems, and the reason it's complicated is because we have 4 vectors. 2 of them are inconvenient, so we have to find the x and y components of those ones. It actually is best to find the vectors, the components for all of the vectors. So if we do A, all of A is in the x direction. So XA is 88 meters, and we'll call that's the positive direction because it's going to the right. YA, or the horizontal part of, the vertical part of A is 0. B is easy as well, so the horizontal part of B is 0 because it's all vertical, and then the vertical part of B is the full negative 272 meters, we call it negative because it's pointed down. For C, we need an XC and a YC. We actually have to solve for that using like sine, cosine, and tangent. So to solve for the y part of it, I would probably do sine of 30 equals opposite, which is y of C, over the hypotenuse. Well, C is 136. So then YC ends up being 68. Okay, and it is pointed down, so we'll call that a negative 68. And then to find the x part of that, we could do cosine 30 equals the adjacent, so xc over the same hypotenuse, 136. So our xc is 117.8. That is pointed towards the left, so it's also going to be a negative. So 117.8 to the negative. Okay, now I'm going to erase those, and we'll go ahead and find the parts of D. So we will also need a y, or an xd and a y of D. So to find the y of D, I'm going to use sine of 60, and that equals opposite y over y, that's yd, over the hypotenuse, which is 183. So then when you calculate it, yd equals 158.5, and it's pointed up, so it's going to be positive. And then we would use cosine of 60 equals xd over 183. And our xd is 91.5. It's pointed towards the left, so I'm going to call it a negative 91.5. Okay, now, so the next step in doing one of these problems is to get an x net and a y net. So we're going to go ahead and add all the x's together, add all the y's together, so that we have just one x and just one y. Okay, the x net comes out to be negative 121.3. The y net is negative 181.5. Once you have your x and your y net, you can go ahead and redraw the problem so that you just have one x and one y. Well, our x is negative and our y is negative. So what we're actually trying to find is the resultant displacement. So we're trying to find this r value. Okay, to find the r, we're going to use Pythagorean theorem, so we end up doing 121.3 squared plus 181.5 squared, and that'll equal our r squared. So our r will come out to be 218 meters. We also need to find an angle, and so we'll end up finding that angle right there. You can use tangent, sine, or cosine inverse to do that. I'm going to use tangent, so that'll be the tangent of the angle equals 181.5 divided by 121.3. And when I calculate that, it gives me 56.3 degrees, and we will call that south of west. Okay, in question number 3, it says, in a recent lab which utilized expensive tracks and carts, Aaron and Bud allowed a cart to roll off the track and then off the table with a speed of 208 centimeters per second. The crash of the cart to the floor at a horizontal distance of 96.3 centimeters from the table's edge turned the entire classroom silent. Use this information to find the height of the lab tables. So I drew a picture, and then the next thing I'm going to do is create my x and my y charts so that I can write down what I know. I'm looking for the height of the table, so I'm looking for my change in y. In the y direction, I also know that the acceleration is negative 9.81. And I know that the initial velocity is 0 because this is a horizontal launch problem. In the x direction, I know that my initial velocity is 208 centimeters per second. I don't want that in centimeters per second, so I'm going to move the decimal over 2 spots to the left so that it is 2.08, and that is meters per second now. I know my change in x, they tell me it's 96.3 centimeters. I want it in meters, so I'm going to say it's 0.963 meters. I know the acceleration is 0. And in the y direction, I'm looking for the height, but I don't have enough information to solve that. I need to know 3 different things, and I only know 2. In the x direction, though, I have 3 things. I could find the time and then use that exact same time over here on the y direction. So to find the time in the x direction, I'm going to use this displacement equation. Because our acceleration is negative, the second part of it just goes away. So we have 0.963 equals 2.08 times our time. Okay, plugging that into the calculator gave me a time of 0.46. 0.46. So that's the time in the vertical direction as well. So now I need to solve for my change in y. I use the exact same equation. This time, the first part of it goes away because the velocity is 0 in the vertical direction. Okay, so I have negative 9.81 and then my time squared at the end. So my vertical height then, when I plug it into my calculator, is negative 1.04 meters. Now, the reason that it comes out to be a negative number is because it's falling, because the cart is coming off of the table and it's falling to the floor. It's asking for how high are the tables, what are the height of the tables, so to answer the question, we would just say 1.04 meters high. Okay, and then the last problem, number 4, is talking about an egg toss. They give us that it is a velocity that is launched at an angle, so you can see the picture that I've drawn there. The first part of it says that we need to calculate the horizontal and vertical components of the initial velocity. That's the first thing you do with all launching at an angle problems. So I need to find my VIX and my VIY. I do that by doing cosine and sine. So if I do cosine of 30, that would give me my VIX, and it's over 8.06, and then if I do sine of 30, that would give me my VIY. So the VIX is 6.98 meters per second. My VIY is 4.03 meters per second. And after this, at no point will I ever use that 8.06 velocity again. I'm always going to use my VIX or my VIY. Okay, question B says calculate the time for the egg to reach the midpoint of its trajectory. This is the point where you would want to start your X and your Y charts. So we know the acceleration in both directions. Acceleration is 0 in the X and negative 9.81 in the Y. We also know that our VIX is 6.98. We know our VIY is 4.03. Okay, we are looking for the change in time to reach the midpoint of its trajectory. Well, that point is going to be right here at the very top. At the very top, we also know that the velocity in the y direction is 0 because it briefly stops. So we're going to call it the final velocity, and we are looking for the change in time at that point. So we're going to be solving for time in our y direction. The equation that we'll use is the one that says A equals VF minus VI over your change in time. We plug in our numbers and solve for T, and the time is 0.41 seconds. Okay, to find the total time that the egg is in the air, well, we know that the overall change in y is 0 because it was thrown and caught at the same height. So if this first half of the motion took 0.41 seconds, the second half is also going to take 0.41 seconds. So we can just double the time, and you get a total change in time of 0.82 seconds. Now this only works when your change in y equals 0. If the change in y is not 0, then you can't just double it. You would have to actually solve for it using one of the equations. Okay, to calculate the horizontal distance with which the egg traveled, that means we're looking for a change in x. If we write down everything else we know about x, well, to get the total distance, we know what the total time was. We just calculated that, 0.82 seconds. We also know that the VIX was 6.98, and we know our acceleration is 0. So if we use this equation and plug in all of our numbers, we can go ahead and solve for that change in x. So we have 6.98 times our time of 0.82. The rest of the equation goes away because acceleration is 0, and we get 5.7, and that unit is meters. Okay, the final question is calculate the height of the egg at its peak trajectory. Well, height is change in y, so we're going to write down everything we know in the y direction. We know the acceleration is negative 9.81. We know that the VIY was 4.03. We also know at the peak of its trajectory at the top that the final velocity is 0. And we actually did calculate the time there of 0.41 seconds. So we can use almost any equation that we have in our kinematic equations. Okay, so I'm going to choose this equation right here. The displacement 1/2 VI, which is 4.03, plus 0 times our time, which is 0.41. And that gives me a displacement of 0.83 meters high at the peak of its trajectory.